Hey there, and welcome to this session on how to turbocharge the AWS CDK with AWS Solutions Constructs. If you found yourself staying up till odd hours of the night modeling your infrastructure, or if you simply want more time for building the unique features of your application, then you've come to the right place. My name is Ryan Hayes. I'm a solutions developer with AWS, and today I'll be showing you how to save precious time with Solutions Constructs. Before we get started, this is a 400 level session. That means if you have an appetite for live code and you already have some experience working with the CDK, then you'll be right at home. If this is your first time hearing about the CDK, I invite you to pause this video and check out some of our 200 and 300 level sessions first to set the stage. But without further ado, let's get this infrastructure show on the road. Let's close our eyes for a minute and pretend that you're the CTO of a power company. Your company serves both business and residential customers. As seasons change, you notice it becomes a challenge to balance capacity and demand. During the warmer months, more customers dial up their air conditioning units, and during the cooler months, folks begin to do the same with their heat. Apart from capacity and demand, you notice that when the power goes out, the time it takes to respond to power outages is rather high. Outage reports are also only created based on calls from customers. As the CTO, you'd like to be able to use technology to enable better capacity and demand planning. Additionally, you'd like to be able to proactively detect service issues so that the right teams can respond faster. After reviewing these goals carefully, you decide that collecting power usage data in real time can give you insights that can help with this. So now you jump on over to the drawing board and start sketching out a sample architecture. Starting from the power meter on each customer's home or business, and working your way back to the utility. We'll pretend that your company already uses power meters that are IoT enabled, and that they'll be sending real-time usage data up into the cloud. The point of entry for that data will be through AWS IoT Core, which will take the raw data and filter it through one or more IoT topics. Then it'll send that data over to a Lambda function for some processing. Once that processing is done, the Lambda function will save that data to a DynamoDB table so it can be easily retrieved in the future. And so that's the first half of your cloud solution. You have the ingestion, processing, and storage of that data covered, but how do you start to gain insights on things like demand or potential service interruptions? You could start by pointing another Lambda function at the table that can scan through the data and apply business logic. This business logic could include looking for patterns like heightened demand and certain times or no reports coming out of a specific area. You decide that you want this Lambda function to pull the table every 5 minutes, so you add a CloudWatch events rule to schedule that. Now when it's running, if the function detects something in the data based on your business logic, you'll want to notify the right people. So you decide to add an SNS topic to dispatch a notification so that they can start diagnosing and responding to the problem right away. Taking a step back now, you now have a solid architecture designed for making those requirements a reality. We see the architecture consists of 6 services all wired up together. So now comes the million-dollar question. How long do you think it might take to build this? Would it be a couple of hours, a couple of days, or perhaps even a few weeks? Let's take a step into another dimension, and I'll actually show you how to do it in around 5 minutes using AWS Solutions Constructs. Now, before I hit the start button on the demo, the idea behind building with Solutions Constructs is using groupings of commonly used services to accelerate building your architecture. On the left, I see the Solutions Constructs library, and on the right, I have my architecture diagram from before. Looking at what's in the library, I can see there's a construct called AWS IoT Lambda DynamoDB. I can use that construct for the first part of my solution, so I'll go ahead and start with that. Looking to the left, I also see there's an AWS Lambda DynamoDB construct, so I'll use that to hook up a function that can run business logic to detect patterns on my table storing the data. Next, the function is supposed to pull the table every 5 minutes. So I'll use the AWS events rule Lambda construct to schedule when my function runs. And finally, I'll need to send notifications if an issue is detected by my insights function. I'll grab the AWS Lambda SNS construct to give my insights function that power. Now, as you can see here, by using constructs, we've already reduced the number of objects we'll need to work with from 6 to 4. But you might be asking, how do I connect 2 or more of these constructs together? We'll take a closer look at that and more now. Follow me over to the IDE. For today's lightning round demo, I'm using AWS Cloud 9, and I'll be writing all my code in TypeScript. Before I start building, I'll need to install the AWS CDK, so I'll do that right now from npm. Know how I specify the version number when doing the install. It's important for CDK and Solutions Constructs versions to be matching. Once I have the CDK installed, I'll create a new folder for my project called Real-Time Power Insights. Once I'm done creating that folder, I'll jump into it and run the CDK init command. That'll create a new CDK project inside my folder that I can then start to build off of. Once the CDK init finishes, I'll jump over to the lib folder in my project and open up the stack.ts file. And so now it's time to start building. For the first part of my solution, I'll install the AWS IoT Lambda DynamoDB construct, which will cover the data ingestion, processing, and storage capabilities for my solution. Now, as part of this, I'm also going to install the AWS Lambda CDK package, which will help me define the source code and runtime for the function. Now that I have everything installed for the first part of my solution, I'll add in some import statements in my stack.ts file. First, I'll import the IoT Lambda DynamoDB construct as well as its props object from the Solutions Constructs library. Then I'll add a second import statement for the AWS Lambda CDK package that I just installed. So now I have everything installed and imported that I'll need for this step. Let's get to the building. I'll go ahead and initialize an IoT Lambda DynamoDB object in the stack file, and I'll set it to a variable so that I can use the pattern resources later. Then I'll flesh out the properties for the Lambda function and the IoT topic. For the Lambda function, I'll tell it where to look for the source code that it'll be running. In this case, it'll be an index.js file inside a folder that I'll create in just a minute. I'll also specify the runtime, which I'll set as Node.js version 12, and then I'll specify the handler name, which will be the usual index.handler. For the IoT topic now, I'll add properties for the topic payload, including rule disabled set as false. I'll also add a brief description, a SQL statement, and finally an empty actions array that I could come back to at a later point in time. Now, as I mentioned before, the Lambda function that I just configured is going to need some source code to run. So what I'll do now is set up a subdirectory under lib that matches the code location I provided in the Lambda properties. I'll create a new folder called Lambda, another one underneath that called processing, and finally an index.js file which will hold some sample code. I would then theoretically come back at a later point in time and add some business logic here for processing the incoming data. But for now, that's a wrap on the IoT Lambda DynamoDB construct. I have my data ingestion, processing, and storage all fleshed out here. Now it's time to move on to the second part and create my insights function. For this, I'll start by installing the AWS Lambda DynamoDB construct. Once that's finished installing, I'll scroll up and add an import statement for it at the top of my stack file here. Then I'll scroll down a little bit and initialize the Lambda DynamoDB construct in my code. I'll also assign it to a variable so that I can link it up with other constructs later on. Next, I'll set up the properties similar to how I did it the first time. I'll give the Lambda function a place to look for some code to run, and I'll also specify the runtime and the handler for it. After I'm all finished with that, I'll link this construct with the first one using the existing table object property, which will pull in the table for storing data that I created in the previous step. Now, this is an important thing to note here. When I set the existing table object property of my Lambda to DynamoDB construct here, it'll read in the table that I provided, make the appropriate connection, and not provision a new one as it normally would. This is how we can effectively start to link multiple constructs together to build a larger architecture. But keeping on with our solution today, and as I did with the first Lambda function, I'll need to give this one some source code to run. So I'll create another folder under lib/lambda called insights, and then I'll add a sample code file there. Once I have my code in there, I should be all finished with adding my insights function. Now, to sum it up so far, I have my data ingestion, processing, and storage fleshed out, and I've just pointed another function at my table that could run business logic for generating insights. Now I'll move on to the third construct, which will add a CloudWatch events rule so that my insights function can run every 5 minutes. To do this, I'll start by installing the AWS events rule Lambda construct from npm. Then I'll also install the AWS Events CDK package to help me define the schedule that my function will run on. Once that's finished, I'll scroll back up to the top and add an import statement for the events rule to Lambda construct. Then I'll also add a second import statement for the AWS Events CDK package that I just installed. Now I'll scroll down a little bit and initialize the construct in my code. I'll use the existing Lambda object property to link it up with my insights function, and then I'll specify a schedule to run it on using the event rule props object. I'll set my function here to run every 5 minutes using the schedule property. And so that wraps up the scheduling component, which brings me to the final piece of the puzzle. This will be the notification service that my insights function can use to send messages to appropriate staff members if an anomaly is detected. For this, I'll install the AWS Lambda SNS construct from npm. Scrolling back up to the top, I'll go ahead and add an import statement for my AWS Lambda SNS construct. Then I'll scroll back down and initialize the construct in my code. I'll point it to my insights function using the existing Lambda object property, and I'll let the default configuration take care of the rest. Now let's take a look at what I've built in that very quick 5 minutes or so. Looking at my stack file, I have about 50 lines of TypeScript code now, and so I'll build and synthesize it to see what it looks like. Now I see I have some output in the console, as well as a CloudFormation template up in the cdk.out folder. When I scroll through this CloudFormation template, I can really see how much time and effort I saved by using Solutions Constructs compared to traditional CloudFormation. So let's flip back to our architecture and recap on the conceptual level. It's important to note that this is just one of the many ways that we could build a solution like this on the AWS cloud. We built an architecture that'll help our company generate insights using real-time usage data from consumers and businesses. Instead of configuring each service individually, I used AWS Solutions Constructs to implement them as bigger pieces of the architecture. First off, I used the AWS IoT Lambda DynamoDB construct to add resources for ingesting, processing, and storing the data being collected. Next, I used the AWS Lambda DynamoDB construct to add a function that can run business logic to generate insights from my data. I use the existing table object property here to point this function at the table created in the first step. Then I use the AWS Events Rule Lambda construct to add an events rule that'll run my insights function every 5 minutes. I use the existing Lambda object property to point the events rule to the Lambda function from the last step. And finally, I use the AWS Lambda SNS construct to send out alerts if an anomaly is detected by the insights function, such as a power failure. I use the existing Lambda object property to point the SNS topic to my insights function. And so to sum it up, I used 4 solutions constructs here to streamline configuring about 6 or more CDK constructs. This made my development more efficient, and it translated into about 14 resources being configured and staged with just a few lines of TypeScript code. Those other resources include things like roles, permissions, and policies. So as we're all familiar, the CDK helps us really streamline building our infrastructure from CloudFormation. And Solutions Constructs helps us get even further along with some of those efficiencies. So now that I have you in the builder mindset, let's dive into what Solutions Constructs are, talk a little bit about how they relate to the CDK, and how you can turbocharge your development experience with them. I'll also cover some key benefits, as well as what to expect from the library looking forward. AWS Solutions Constructs are higher-level abstractions of AWS CDK constructs. They wrap multiple of these CDK constructs together to create common, reusable groupings of architecture. They also come pre-configured so that your architecture will adhere to AWS best practices right out of the box. This allows you to save precious development time for building the unique features of your solution, and it reduces the amount of repetition in configuring resources on the individual level. Solutions constructs also work seamlessly alongside CDK constructs, so you can leverage the power of both libraries to build out your solution. At the bottom, you can see the anatomy of a typical solutions construct. The AWS Lambda DynamoDB construct consists of the following items. It comes with a Lambda function, it comes with a DynamoDB table, and then it also has any necessary configuration for that Lambda function to be able to interact with the DynamoDB table. Finally, it also comes with a set of best practice defaults for you to be able to hit the ground running with development. In this particular case, some examples of those best practice defaults would include providing a least privilege access role through IAM for the Lambda function and enabling retention on the DynamoDB table. Now you might be asking, I'm seeing and hearing a lot about these AWS Solutions Constructs and CDK constructs. What's the difference between the two? The answer here is CDK constructs have a single service focus. This means that if you add a Lambda function CDK construct to your project, you'll simply get that Lambda function and any complementary default resources, like the execution role, for instance. On the other hand, Solutions constructs have a multi-service focus. This means that if you add an AWS IoT Lambda DynamoDB construct to your project, similar to what we did in the demo today, you'll get the following in there. You'll get the IoT topic rule, you'll get a Lambda function, and you'll get a DynamoDB table. And finally, you'll also get the set of best practice defaults that configures it for use right out of the box. This can help you save a lot of time from configuring individual CDK constructs to achieve the same functionality, as well as additional time spent ensuring that they adhere to best practices. It's also important to note that since Solutions constructs group together 2 or more CDK constructs, they also inherit the same defaults that the CDK constructs have, which makes configuration even easier. The workflow for building with Solutions constructs is very straightforward, and if you already have experience building with the CDK, then the experience will feel very much the same. If you're starting from scratch in a new development environment, you'll need to start by installing the AWS CDK. This will provide you with all the command line tools needed to start, build, and deploy your solution. This can be done with a simple npm install command. Now, after you're done bootstrapping your dev environment with the CDK, you'll need to set up your new project. I always recommend using the CDK init script to do this, as I showed in the demo earlier. This script will install all the necessary dependencies and set up your file structure so that you can get right to building. Now, those are pretty much the 2 preliminary steps you'll need to get started. After that, you can install a solutions construct from your package manager of choice, add an import statement for it in your code, and configure the properties for it as needed. It's important to note that while each solutions construct comes with best practice defaults, they're also fully customizable, and any defaults can be overridden if needed to fit your particular use case. You can repeat these 3 steps as many times as needed with both solutions constructs as well as CDK constructs until your project is fully fleshed out. Now, building with solutions constructs offers some key advantages that really turbocharge your experience with the CDK. The experience is even more amplified if you currently use CloudFormation for your modeling. To start, the library helps you accelerate delivery of your projects. It gives you the power to write the equivalent of hundreds or even thousands of lines of CloudFormation code in few lines of TypeScript. And if you're a CDK user, it helps you remove some of the repetition in configuring the same constructs over and over again. This lets you spend more time on the noteworthy features of your application and less time re-implementing the wheel with your infrastructure. It also reduces the burden of ensuring that your architecture is up to par with AWS best practices. Now, speaking of best practices, each solutions construct ships with a set of best practice defaults. These defaults allow you to use them confidently out of the box, without having to worry about researching and configuring each service to meet those high bars. While each one comes with these defaults, they're also fully customizable, meaning that you can tweak the defaults or any other configuration as needed to fit your particular use case. When you build with solutions constructs, you get the same great QA capabilities that the CDK offers as well. Since your infrastructure is written using modern programming languages, you can enjoy the benefits of using your favorite test suites, such as Jest, to build automated tests. This is a big step forward, especially for CloudFormation users, as it adds several layers of assurance around your infrastructure that you simply just can't get with template-based modeling. Finally, your infrastructure becomes more maintainable when you build with solutions constructs. By reducing the lines of code and number of objects being defined, you make it easier for future agile iterations to happen. And you also have a much cleaner and sensible code base. Now, another advantage here is that you can now have a unified development experience for both your infrastructure as well as your business logic. As you saw in the demo today, I was able to define both the code for my infrastructure as well as the code for my Lambda functions within the scope of the same IDE. This really helps tighten the gap between those two domains and prevents having to switch between tools during the development process. One of the success stories I'd like to share around solutions constructs actually comes from right here at AWS. Over the past year, AWS Solutions updated the serverless image handler solution. This update changed the infrastructure from a single monolithic CloudFormation template to a more lightweight CDK project written in TypeScript. Now, for context, serverless image handler is part of the AWS Solutions Implementations portfolio. It provides developers with a ready-to-deploy image API. Instead of serving original size images to every device that's using your application, the API delivers images optimized for each user's device. This helps improve the user experience by giving them faster load times and in many cases reduces the amount of data being consumed. As part of this update, 2 solutions constructs were used to replace upwards of 20 resources. Each of those resources had to be individually configured and maintained in the past. And as a result, the code density shrunk by over 45%. This was in terms of 850 lines of TypeScript code transpiling into about 1,600 lines of YAML. And this made the solution far more maintainable and easy to parse through by developers. The solution was also outfitted with automated testing. Instead of relying on manual testing processes from before, test cases were able to be built to evaluate the deployment, consistency, and configuration of the solution. In turn, this made it easier to ensure the solution hit the same high-quality bar that others are held to. And it also helped to proactively detect infrastructure bugs that previously required third-party tools and manual scanning of CloudFormation templates. Now, having worked with the library on multiple projects now, I think this serves as a great living example of how solutions constructs can help reduce code density, improve your quality assurance, and make your solutions more maintainable. So let's talk a little bit about where things are at and where they're headed with the library. Solutions Constructs is a living and evolving library of higher-level architecture patterns. It's an open-source project that currently has over 30 constructs, and each construct is available in 3 different flavors: TypeScript, Python, and Java. The library lives on GitHub under the AWS Labs organization. Here, developers are invited to share their ideas, feedback, and any issues that they might bump into. Developers who are interested in being a contributor to the library can also do so through GitHub. We provide our full roadmap here and encourage developers to own constructs that are important to them. One great feature we implemented to streamline the contributor experience is automated build feedback. This provides build logs, error messages, and other outputs right in the pull request. And that gives contributors immediate feedback on their approved constructs and allows them to rapidly iterate on them. Now, looking forward into what's next for the library, we expect continued expansion into new technology categories. One area that we look forward to expanding into is the machine learning space. We actually just released our first pattern in this space not too long ago, which is the AWS Lambda SageMaker construct, and we expect several more to come. Another area that we look forward to building out is the CI/CD category. For this category, we're looking at potential constructs that integrate with AWS developer tools like Code Build, Code Pipeline, and more. You can stay on top of all releases and updates to the library by following the project on GitHub. To wrap up today's session, I invite you to check out these resources online. Here you'll find links to the Solutions Constructs website, our GitHub page, and also the documentation site for the CDK. I've found these resources to be great in building projects, and I hope you find them to be useful as well. Now, as I mentioned on the previous slide, Solutions Construct is an open source library. If you're interested in engaging with the project, you can find all of the resources you'll need on our GitHub page. I also invite you to check out my colleague Biff Gott's session titled Get It Right the First Time, Production-Ready Prototypes, which dives into using Solutions Constructs to close the gap between prototype and production. It's a 300-level session, and I highly recommend giving it a watch. So, thank you for tuning into this session on turbocharging the AWS CDK with AWS Solutions Constructs. Once again, my name is Ryan Hayes. Please be sure to leave us your thoughts and feedback in the session survey after. Thanks for watching, and I'll see you next time.